Next example, solve following assignment problem. Let us apply step 1 of Hungarian method to find optimum solution. So we require smallest number in the first row. What is a smallest number? What are the numbers in the first row? 32, 38, 40, 28, 40. So smallest number is 28. Subtract 28 from all the entries in the first row. We get so 32 minus 28 is 4. Then 38 minus 28 is 10. 40 minus 28 is 12. Then 28 minus 28 is 0. 40 minus 28 is again 12. Then what is the smallest entry in the second row? 40, 24, 28, 21. So 21 is smallest. Subtract 21 from all the entries in the second row, we get 40 minus 21, 19. Then 24 minus 21 is 3. 28 minus 21, 7. 21 minus 21 is 0. 36 minus 21 is 15. Then what is the smallest number in the third row? 41, 27. 27 is the smallest number. So subtracting 27 from all the numbers in the third row, we get 41 minus 27 is 14. Then 27 minus 27 is 0. 33 minus 27 is 6. Then 30 minus 27 is 3. 37 minus 27 is 10. Now the smallest number in the fourth row is 22. So subtract 22 from all the entries in the fourth row. We get 22 minus 22, 38 minus 22, 16. 41 minus 22, 19. 36 minus 22 is 14. And again 36 minus 22 is 14. The smallest number in the fifth row is 29. So subtract 29 from all the entries in the fifth row. We get 29 minus 29 equal to 0. 33 minus 29 is 4. 40 minus 29 is 11. 35 minus 29 is 6. And 39 minus 29 is 10. So this is step number 1. Now apply step number 2. Repeat step 1 for columns. So let us apply step 2, that is repeat step 1 for columns. So what are we have to choose the smallest element in a column and subtract it from all the entries in that column. So in the first column, the smallest entry in the first column is 0, and when we subtract 0, elements will not change in the first column. So the elements are 4, 19, 14, 0, 0. In the second column, smallest entry is 0. So subtracting 0 will not change the numbers in the second column. So the numbers are 10, 3, 0, 16 and 4. In the third column, smallest entry is 6. So we subtract 6 from all the entries in the third column. So 12 minus 6, 7 minus 6, 6 minus 6, 19 minus 6, 11 minus 6. Now in the fourth column, smallest entry is 0 and subtracting 0 will not change the elements. So the elements in the fourth column are 0, 0, 3, 14 and 6. In the last column, smallest entry is 10. So subtracting 10 from all the entries of fifth column, we get 12 minus 10, 15 minus 10, 10 minus 10, 14 minus 10, 10 minus 10. So this is a cost matrix obtained in step 2. Now we perform step 3. Cover all zeros with minimum number of horizontal and vertical lines. So step number 3 is cover all zeros with minimum number of horizontal and vertical lines. So we begin with the first row and look at the rows containing single zero. In the first row, we have single zero in the first row. So make an assignment here in a row in the first row. And when we made an assignment in a row, we have to draw a vertical line. Now in the second row, there is no single zero. This zero is already crossed. Now in the third row, there are 3 zeros. In the fourth row, there is a single zero. We use it for an assignment and draw a vertical line. Then in the fifth row, there is a single zero. This zero is already crossed. Now this is a single zero. We can use it for an assignment and draw a vertical line. Now after fifth row, we look at the columns. Column number 1, there is an assignment. Column number 2, there is a single zero. So use it in the for an assignment. So when we make an assignment in a column, we have to draw a horizontal line. Column number 3, there is no zero. So we have covered all zeros with horizontal and vertical lines. How many lines we have drawn? 3 vertical and 1 horizontal. So total 4 lines. So number of lines are 4. It is not equal to order of the matrix. order of the cost matrix, given matrix, and it is 5 by 5 matrix, so its order is 5. So 4 is not equal to 5. So this is not an optimum solution. We have to apply step 4. Now what is step 4? So this is a step 4. Subtract the lowest uncovered number in the matrix from all the uncovered number. Now what is the smallest uncovered number here in the cost matrix? What are the uncovered numbers? 10, 3, 16, 4, 6, 1, 13 and 5 are uncovered numbers. So 1 is the smallest uncovered number. So here the smallest uncovered number is 1. So we have to subtract it from all the uncovered numbers. So we have to subtract it from 10, 6, 3, 1, 16, 13 and 4, 5. Add the same number to the numbers which are on the intersection of horizontal and vertical lines. So what are the numbers on the intersection of horizontal and vertical lines? 14, 3 and 0. So we have to add 1 to these three numbers and do not change other numbers. So this is a step number 4. So let us apply this step number 4. Now we will write the elements in the first column. So let us write down the entries in the first column. 4 and 19 do not change. So we write 4 and 19 in the first column. Four and 19. Next, other entries on the intersection of horizontal and vertical line, we have to add the smallest uncovered number, which is 1. So 14 plus 1 is 15. Next number in the first column is 15. Then other numbers are 0, 0. Do not change these two numbers. Let us write down elements in the second column. 10 and 3 are uncovered numbers. So we have to subtract 1 from the all uncovered numbers. So 10 minus 1 is 9 and 3 minus 1 is 2. 9 and 2 are the numbers in the second column, first two numbers. Then next number is 0, do not change 0 because it is on the line. Then other two numbers are uncovered numbers. So subtract 1, we get 15 and 3. 16 minus 1 is 15, 4 minus 1 is 3. So 15 and 3. Then the numbers in the third column, 6 and 1 are uncovered numbers. So subtract 1, 6 minus 1 is 5, 1 minus 1 is 0. We get 5 and 0 in the third column, first two numbers. Next number in the third column, 0, do not change 0 because it is on the line. Then 13 in the third column, other two numbers are 13 and 5. Both are uncovered. So subtract 1. 13 minus 1 is 12. 5 minus 1 is 4. So 12 and 4. Now let us write down elements of the fourth column. 0, 0. On the intersection we add 3 plus 1 is 4. So 0, 0, 4 are the numbers in the fourth column. Other two numbers are 14 and 6. Do not change. 14 and 6. Let us write down entries in the last column. 2, 5 as it is, 0 plus 1. We add 1 in on the intersection. So 2, 5 and 1. Other two numbers are 4 and 0. Do not change 4 and 0. So this is a step number 4. We obtain this matrix, and we have to again apply step number 3 on this cost matrix. After applying step 4, we have to repeat step 3. So let us apply step 3. Cover all zeros with minimum number of horizontal and vertical lines. Look at the numbers, look at the rows containing single zero. So first row contains single zero, so we make an assignment here and we will draw a vertical lines because we have made an assignment in a row. Now in the second row there is a single zero because this zero is already crossed. 1 0 is already crossed, so there is a single zero here in the third column. So we make an assignment and cross, draw a vertical line. In the third row there is a single zero here, so we make an assignment and again draw a vertical line. In the fourth row again there is a single zero, so use it for an assignment and draw a horizontal line. In the last row there is a single zero, we make an assignment and again draw a vertical line. So how many lines we have drawn? 5 lines. All are vertical lines. So the number of lines are 5. It is equal to order of the cost matrix. So it implies that we have obtained the optimum solution for this assignment problem. Therefore, this assignment is an optimum assignment. So what is the optimum assignment? The optimum assignment is so first job is assigned to the machine D, second job is assigned to the machine C, third job is assigned to the machine B, Fourth job is assigned to the machine A. Fifth job is assigned to the machine E. And what is the optimum assignment cost or minimum assignment cost is? Now, first job is assigned to the machine D. So the cost of performing first job on the machine D is C14. And what is the cost C14? C14 is this 28. Then second job is assigned to the machine C. So the cost of assigning second job to the machine C is C23. C23 is 28. Then third job is assigned to the machine B. So the cost of performing this job, third job on the machine B is C32. C32 is 27, third row, second column. Then next job. Fourth job is assigned to the machine A and the cost is C41. C41 is fourth row, first column entry. It is 22. And finally, job 5 is assigned to the machine E. The cost of performing this job 5 on machine E is C55. C55 is 39. So these are the smallest. We have to add all these costs and we will get smallest cost of performing all 5 jobs on the given 5 machine. So we add these numbers 28, 28 and 27. Then 22 and 39. Now 28 plus 28 is 56. Then 27 plus 20 is 49. And last is 39. So 144 is the cost. This is the smallest cost of performing all the 5 jobs on 5 machines obtained by using Hungarian method.